Hello everyone, welcome to my channel, Mutlu Learning Hub. Today's title is Supervised Learning in Action. Today we are going to start with a recap of the previous video, then we are going to focus on supervised learning, regression and classification. But it won't be very mathematically heavy, we are just going to try to understand the main idea behind that. Let's do our recap. We discussed the statistical learning. Statistical learning was trying to find the patterns in the data. As an equation, I can write it like this. Here, X is the input, F is the pattern that we found, and epsilon is the noise or uncertainty in the data. We had two types of statistical learning. First one is supervised learning. To do supervised learning, we need the labeled data. But for unsupervised learning, we don't need the labeled data. We discover the hidden structure in the data. And to find this pattern, we have two different methods. First one is parametric method. Here we assume that f is a function, but when we do non-parametric method, we don't assume that f is a function. What's next? We are going to focus on supervised learning, and we are going to compare regression and classification. Our main question is the following. Are we predicting a continuous number or a discrete category? When we do regression, we predict a number, or you can say continuous output. When we do classification, we predict a category, or you can say a discrete outcome. As you see here in our plot, we are trying to predict the total views of a video in 24 hours. But in the classification example, we try to predict whether a video is going to be a hit or flop. That is the main difference between the regression and classification. Now, let's focus on regression. Let's focus on regression. Here is our example. We want to predict the total views a video will get in 24 hours based on early engagement metrics. Here our inputs, or one could say features, could be views in first hour, likes, or shares. And the output is total views in 24 hours. Let's look at our plot. On the x-axis, we have our input. It could be views in first hour, likes, or shares. On the y-axis, we have the output, total views in 24 hours. As you see, it's a continuous number. And here, since there is a linear trend, we use linear regression. Let me write the form. One could ask, how did we find this nice line? Finding this nice line is called training. I'm gonna focus on training later on. But let's remember the main goal of a regression. We want to estimate a number based on observed patterns. Now let's focus on classification. Here we have an example. We want to predict whether a video will be a hit or flop using the engagement metrics. We have similar inputs like views in first hour, likes, and shares. And the output is a video is a hit or flop. Let's look at our plot. Here on the x-axis, I have one feature, views in first hour, and y-axis, I have the likes. And we already have the labels, so our model already knows the labels. It's a hit or flop. As an example model, I want to talk about the k nearest neighbors. K nearest neighbors. And what does it do? So it already knows whether a video is a hit or flop. Model memorizes that, and then when a new video comes in, we can see it here, and then we look at the nearest K points around it, and then we do majority voting. If the blue points are more than pink points, we say it's a flop. Otherwise, we say it's a hit. Again, I'm going to talk more about it later on. Let's remember the main goal of a classification model. We want to decide which category something belongs to. Let's recap what we did. So we focused on supervised learning. We have a labeled data, and from that labeled data, we want to predict the outcomes. We discussed the regression. When we have regression, we want to predict continuous number. And for the classification, we want to predict the categories. What's coming up next? We want to talk about model training and evaluation. And thank you, everyone.